Throughout the semester, we learned about a lot of topics, and one of the topics that we covered pretty in depth was the idea of the bottleneck, the cycle, and the cycle time. So one of the things you can learn from a cycle, which can be any process, whether it be in a factory or in a service setting, like if you're at a bank, you can learn about like your product turnover and all these different things. One of the things you can learn about is cycle time, and you can use your cycle time to determine your efficiency, and also you can look at your entire process overall and determine which parts need a little bit of tweaking and which parts you're doing really well. So to determine this and to use this cycle as part of our example, we're just going to use a simple 3-station process. So for this example, we'll call this station A, this station B, and over here we'll have station C. Now for each of these processes, we're going to need 2 more pieces of information, and that is the time of each one of these stations and also the number of employees. So for this problem, we're going to do station A at 15 minutes, station B at 10, station C at 5. And for the number of employees, we're going to just do 1, 3, and 1. So when looking at this, initially we can determine that A is the bottleneck, which makes our capacity per hour 4, because 15 goes into 30 twice, flip that, you get 4 out of an hour. So we know that 4 is the absolute maximum that we can have. That's our capacity max. So to improve upon this capacity max, we know that we need to get this bottleneck number way down. In order to do that, we look at the employee layout, and we determine that to get your employee efficiency for every employee up to the maximum, we need to do something about this one employee that's taking on 15 minutes of work. Because we see that one employee in station C only has a 5-minute workload, and one employee in station B only has a 3.33-minute workload. So if we redistribute one employee from station B to station A and make this 2, 2, and 1, without adding any jobs to your stations, any new employees, we cut the time down by half to 7.5 minutes. And then here, because we lost one employee, we add in the 3.3 minutes of work. 13.3 minutes for the 2. Whoops. And then we still have the 1 employee at 5 minutes here. Now, because this did go up to 13.3, which is above the 7.5 mark, this is the new bottleneck, but this bottleneck allows us to get almost 2 more full units per hour, as opposed to the 15-minute, or 1 full unit, excuse me, as opposed to the 15-minute mark. So by being able to move our bottleneck from station A to station B, and also by being able to reduce our bottleneck by nearly 2 full minutes, in that one simple step, we were able to take a look at our entire cycle, determine our capacity maximum for our entire cycle, look at the breakdown and the workload of every individual employee, and also determine what would be the best formation to restructure our employees so we'd be able to have the most efficient cycle possible. So that's how the idea of cycle time has been applied throughout the semester and how it can help you in your business decisions.